In certain circumstances, you may find that your scatter plots are difficult to interpret. You might have an extremely large number of data points, such that a standard scatter plot leaves an undetailed blob. Or your numeric data might be discrete in nature, making it difficult to see the distribution of data. Can you tell what's going on in either of these plots? Me either. Conditions like this, where you have too many points in a small area, are called overplotting. In these cases, techniques like sampling, transparency, and jitter can allow you to build scatter plots where you can better detect patterns and relationships. Take, for example, this plot of 10,000 data points generated from a couple of bivariate normal distributions. It's hard to tell where the drop-off in density is from the distribution's peaks and how fast it occurs. One way of solving this is to use random sampling to plot a smaller number of points, let's say 800. We can clearly see the gap in peaks where fewer points are plotted. The random selection of points still gives us a good intuition for the general distribution of data. As an alternative strategy, we can still plot our original 10,000 points, but plot each point with some transparency instead. Each individual point will be lighter in color, but when points overlap, the overlapped region becomes darker. The two darkest regions are those with the highest number of points, indicating the peaks of the distributions. Since a higher density results in a darker color, we have, in an implied way, used color to augment what would have been obscured from using position alone. But what if one or both of our variables are discrete? Sampling doesn't help at all, because any number of overlapping points all look the same. Transparency allows us to make density judgments based on color, but this loses some of the power available in positional encodings. This is one case where we will want to add some jitter. Jittering adds a small amount of random noise to the position of each point, so that multiple data points that have the same values are now spread over a small area. As long as the jitter keeps each of the discrete values in distinct bands, this can be a big help in the identification and interpretation of trends.